Hello guys, welcome on Tesla Adventures. Now in this video we'll be discussing the river boat problems, which are most important problems of relative motion. And after this video we'll be discussing the numerical problems which are based on river boat problems, and that too of level 1 and level 2. So let us first of all start the basics of riverboat problem. You can see that first of all, let us discuss the meaning of VR and VB. This VR is velocity of river flow, or velocity of stream, or velocity of current. These are different names which are used in different books, and you would be facing these names in different books and sources. So these are all same, and this is referred to the velocity of river. Now VB is the velocity of boat with respect to river. Now what does it means? It means that if river is at rest, then why that boat is moving. So you can imagine that if river is at rest, that boat would be moving due to its engine also only. And obviously in that case, if the river is at rest, the boat or the swimmer is moving due to its engine or strokes. So we can refer it as the velocity of boat with respect to river. We can also refer it as the river velocity of boat, or the velocity of boat due to its engine, or the velocity of boat in still water. These are all same things. So you have to notice a very important thing, that VB is always the velocity of boat with respect to river, which means that if river is at rest, then what is the velocity of boat? And obviously if river is at rest, then boat would be moving due to its engine only. Okay, now let us discuss some basic cases. Now this case 1 is the downstream case. Now downstream means that the river and the velocity of boat are in same direction, and you can imagine that there is a observer A which is sitting in a boat which can move with the velocity of VB due to its engine, and this boat is moving in the direction of the river velocity with the velocity VB with respect to the river, and the river is flowing with the velocity VR, and there is an observer C which is sitting on a wooden log which is floating in this river. So first of all, let us discuss that what are the velocities of A, B and C with respect to each other. First of all, let us write down the velocity of A with respect to, in fact, velocity of C with respect to B. Now you know that B is a ground observer. This is a ground observer. So for a ground observer, the velocity of C will be the velocity of river, due to the fact that C does not have any engine. So the C is sitting on a wooden log which is floating in the flowing river. So the velocity of wooden log will be equal to the velocity of river, and therefore we can say that the velocity of C will be equal to VR with respect to the ground. Okay, this is a obvious thing. You can imagine that. Now VB, VA with respect to ground. Now we know that, or ground we can term as ground as B. So this is velocity of A with respect to B. Now you can see that let us take an example, that if there is a train which is bullet train which is made up of glass, and it is moving with a speed of 120 kilometers per hour, and for a observer standing on the ground, he is watching a boy inside the train which is running in the direction of train, and that boy which is running inside the train is running with a speed of 20 km per hour with respect to a passenger which is sitting inside the train, which means that that boy is running with a speed of 20 with respect to train. So can you guess that what would be the velocity of that boy with respect to a ground observer? So easily you can figure out that the velocity of that boy with respect to the ground observer would be the sum of velocity of that boy plus velocity of that train. So it would be 120 plus 20, which is 140. So this is a very simple case. So the same case is in this situation, that in this situation river is flowing with the velocity of VB, in fact VR, and the boat is moving in that river with the velocity of VB with respect to river. So the ground velocity of boat would be the sum of these two velocities, which is VB plus VR. You can imagine that if that river is flowing with the velocity of 10 meters per second, and there is a boat which can move in a still water with a velocity of 20 meters per second, and in this case that boat is moving at full throttle, which is the full throttle velocity is 20 meters per second in the direction of river flow, as well as river is flowing with the velocity of 10 meters per second, then we can easily say that the velocity of that boat with respect to the ground would be 10 plus 20, which is 30. Okay, now the velocity of that boat A with respect to C. Now obviously we know that C is the observer which is flowing with the speed of river. So this is the velocity of A with respect to river only. And we know that velocity of A with respect to river is VB itself. So this would be VB. So guys, this is very important to understand that what does VB signifies to solve the riverboat problems. So I hope that you got this situation correctly. Now in the case of upstream, when the boat is moving in the opposite direction of the river current, let's suppose in this direction, with the velocity VB, which is the velocity of boat with respect to river. So in this case, if you write down the velocity of boat with respect to ground, which is B, then considering the fact that VB is greater than VR, you can imagine or you can assume that VB is greater than VR. So VAB, velocity of this boat with respect to ground, would be obviously VB minus VR, because you can take an example that if in still water a boat can move with velocity of 20 meters per second at full throttle, and river is flowing with the velocity of 10 meters per second, and boat is moving in the opposite direction of the river flow, which is called as upstream, then you can see that the net velocity of boat with respect to ground would be 20 minus 10, which is 10. So this is the velocity of boat with respect to ground, and the velocity of boat with respect to C is the velocity of boat with respect to river itself, because C is the part of a river. So you can say that it would be VB in the backward direction, and this is also in the backward direction, this is also in the backward direction. And velocity of C with respect to B in this case is again VR in the forward direction, because this C is the part of the river and it is flowing with the speed of river. So observer B would be observing C to be moving in the direction of river with the velocity of river. So this was the second case, which is the upstream case. Now let us move on the third case. In this case, this observer needs to cross this river in the shortest path, which is AB. You can always imagine that the shortest possible path to cross the river is AB, the perpendicular path to the river flow. Okay, so this is very simple case. Now zero drift, what is drift? Now let us see that if this observer or if this boat is traveling in this direction, is trying to travel in this direction along AB, then it would not reach this point B. In fact, it would get drift in the direction of river flow, like that, due to the river flow velocity. River will drift this boat in the direction of x-axis. Okay, so in that case there would be some drift, but this boatman wishes to reach just this point B, which is directly opposite to the point A. So you can you predict that in what direction he should be trying to move? in direction 1, direction 2 or direction 3? So obvious answer is direction 1, because in this direction if he would be trying to move, then he could cancel the effect of river velocity. Let's see how. Let us suppose that he is moving with a velocity Vb, or he is trying to move with a velocity Vb at some angle theta. Now in this case what happens, that there is a component of Vb in the backward direction which is Vb sine theta, and there is a component in the direction of AB which is Vb cos theta. Now if Vb sine theta is equal to Vr, then you can see that sine theta is equal to Vr by Vb, which means that if he is moving at an angle of sine inverse Vr by Vb, then obviously he would be reaching just at point B, because you can see that the velocity of boat with respect to the ground in x-axis would be 0. Let us see this case. Now let us write down that this point is C. So this C point is not the point where he would reach. In fact, he is trying to move in the direction of AC, but eventually due to the effect of river current he would be moving in the direction of AB, and the real path of this boat would be AB with respect to ground. Okay, so let us see that the path of boat with respect to ground would be AB. Obviously AB would be the path of this boat with respect to ground, and the path of this boat, path of the boat with respect to river, is the path at which this boat is trying to move, and this path is AC. So this is AC. Okay, now obviously this is a understood thing, that the velocity of boat with respect to the river is equal to Vb along AC. Vb is along AC, but velocity of boat with respect to ground would be Vb cos theta along AB. So with respect to ground, this boat would be moving like that. So obviously you can see that the velocity, if this is x-axis and if this is y-axis, then the velocity of boat in x-axis. Now when I am writing that velocity of boat in x-axis, then it automatically means that this velocity is with respect to ground. So in x-axis the velocity of boat would be 0, and in y-axis the velocity of boat would be equal to Vb cos theta. Okay, so this is the velocity of the boat. So I hope you have understood this concept. Now let us move further. Let us analyze this result. So we have already derived that to move from A to B directly, he needs to move at an angle of theta with this perpendicular direction, and theta, sine theta is Vr by Vb. Obviously this is possible only if Vb is greater than Vr, because sine theta is always less than or equal to 1, or we can say that this angle is acute angle, obviously you can see, so sine theta would be less than 1. So this zero drift is only possible when Vb is greater than Vr, or in other words I can say that if a component of Vb is cancelling out Vr, then obviously this component of Vb is equal to Vr. And if a component of a vector is equal to another vector, then that original vector would be greater than this vector, obviously. Okay, so this is the case. To cross the river in shortest path or zero drift, it is necessary that Vb should be greater than Vr. Now let us find out the time in which it would cross the river. So the time of crossing the river depends on this y direction, because to cross the river he needs to move this w distance, which is the width of the river. So the time would be equal to the width of the river upon Vy, and we know that Vy is equal to Vb cos theta. So it is Vb cos theta. This is the time it would take to cross this river. Okay, now let us see that what is the direction in case in which he would like to cross the river in shortest time. So you can see that to cross this river in shortest time, let us analyze the direction. So can you predict that in what direction, in 1, 2 or 3, in which direction he should be trying to move so that he crosses the river in the shortest time? So in the previous case, in the last case, we have derived a result that this time is equal to w by Vb cos theta. So this time in previous case is w by Vb cos theta in previous case. So to minimize the time, for minimum time, you can see that cos theta should be maximum, and the maximum value of cos theta is equal to 1, and it is when the theta is equal to 0 degree. So it is obvious that this boat should try to move along this direction with velocity Vb with respect to water, but in this case he would not reach the point B because river would drift this boat in the direction of river flow. So he would be reaching at this point. Okay, so this is point C. Let me tell you another important velocity component of this case. I forgot to tell. Now you can see that if we analyze this Vb cos theta, then sin theta is equal to Vr by Vb, which we have already written, and cos theta will be equal to under root of Vb square minus Vr square upon Vb. So the velocity Vy, which is Vb cos theta, is equal to Vb into under root of Vb square minus Vr square by Vb. So it is under root of Vb square minus Vr square. So if in case you forgot that, you had a confusion in exam that whether this formula is under root Vb square minus Vr square or it is under root Vr square minus Vb square, you could just realize that which is greater, because this formula should always be, this term should always be positive, because otherwise this would be an imaginary term. Okay, now again coming to this case, that the case in which we have to cross the river in shortest time, we have already discussed that he should be trying to move along this direction. So if I find out the path of the boat with respect to ground, so that path would be AC, and path of boat with respect to river would be AB. This would be the path of boat with respect to the river. Okay, so this is a very obvious thing. Now this would be the resultant velocity of the boat, because the velocity of boat is having another effect of velocity of river, and Vr and Vb adds up to Vr. So Vr vector plus Vb vector is equal to Vr. Just be aware of the fact that this is a vector addition, not a scalar addition. So you can't just add the magnitudes of Vr and Vb like that. You can see that these two are perpendicular to each other. So resultant velocity or resultant speed would be under root Vr square plus Vb square. Okay, in this case. So I can say that with respect to ground, or velocity of boat with respect to ground velocity would be equal to VR I cap plus VB J cap, but velocity of boat with respect to river is only VB J cap. This is very simple to understand. Now we have already calculated the minimum time, which was T minimum was when this theta is 0 degrees. So T minimum is W upon VB. This is the minimum time to cross the river. And if we find out the drift which it got due to the river flow del, which is the distance BC, we can find out this drift by a simple fact that the time taken, obviously the drift is due to the river flow. So the net velocity of the boat in this direction is only VR, and the net velocity of the boat in Y direction is VB only. And drift is the displacement of x-axis. So in x-axis, I can say that in x-axis the velocity of boat is equal to velocity of river, and it would be equal to the drift upon time taken to cross river. So drift would be equal to VR into T. So del would be equal to VR into T. T is W upon VB. So it is W upon VB. So del is equal to VR into W by VB. You can also find out this del by a simple vector approach, that this is VB and this width is W, this is VR and this width is del. So if we wish to find out this angle tan theta, then tan theta will be equal to VR upon VB if we are writing the tan theta in terms of velocities, and tan theta in terms of distances would be del upon W. So del would be equal to WVR by VB. This is del. Okay, so this is the case of the river in which he wishes to cross the river in the shortest time. Now in the next video we'll be discussing that what happens. We have already seen in this video that to cross the river in shortest path, it is necessary that VB should be greater than VR. But in next video we'll be concerned with the minimum drift if VB is less than VR. Obviously if VB is less than VR, then minimum drift cannot be 0. What do I mean to say? That if VB is less than VR in this case, then VB sin theta is obviously cannot cancel VR. So there would be some component of this river boat velocity in x also in this case. So it would get drift somewhere like that, and we have to minimize that drift in the next case. So I'll be bringing that video following this, and keep tuned for the more concepts. Thank you.